Section 1110, Partial Pressures, Dalton's Law. Many gas samples are a mixture of gases. For example, the air that you breathe is a mixture of mostly oxygen and nitrogen gases. In an ideal gas mixture, scientists observe that all gaseous particles behave the same way. Therefore, the total pressures of the gas in a mixture is a result of the collision of the gas particles regardless of what type of gas they are. In a gas mixture, each gas exerts its partial pressure, which is the pressure it would exert if it were the only gas in the container. Dalton's law states that the total pressure of a gas is the sum of the partial pressures of the gases in a mixture. Dalton's law. Total pressure is the sum of all the partial pressures, P1 plus P2 plus P3, so on. Suppose we have two separate tanks, one filled with helium at a pressure of 2 atmospheres and the other filled with argon with a pressure of 4 atmospheres. When the gases are combined in a single tank with the same volume and temperature, the number of gas molecules, not the type of gas, determines the pressure in the container. There, the pressure of the gas mixture would be 6 atmospheres, which is the sum of their individual or partial pressures. Air is a gas mixture. The air that you breathe is a mixture of gases. We call the atmospheric pressure is actually the sum of the partial pressures of the gas in the air. Table 11.7 lists partial pressures for the gases of air in a typical day. Table 11.7, typical composition of air. Nitrogen has a partial pressure of 594 millimeters of mercury, which is 78%. Oxygen has a partial pressure of 160 millimeters of mercury, which is 21%. Carbon dioxide, argon, and water vapor have 6 millimeters of mercury average, which is 0.8%, and its total air is 760 millimeters of mercury. Gases collected over water. In the laboratory, gases are often collected by bubbling through water into a container. In a reaction, magnesium reacts with hydrochloric acid to form hydrogen gas and magnesium chloride. As hydrogen is produced during the reaction, it displaces some of the water in the container. Because the pressure of water, the gas is collected is a mixture of hydrogen and water vapor. For our calculation, we need the pressure of the dry hydrogen gas. We use the vapor pressure of water at the experimental temperature and subtract it from the total pressure of the gas pressure. We can use the ideal gas law to determine the moles or grams of the hydrogen gas that we collected.